In this video, I'm going to go over some definitions of the basic terminology we're going to use in this class. So the first one is system. System is nothing but it is a combination of interacting elements that perform a function. And one important thing is system need not to be a physical system. Say for example, if you look at our political system, okay, so the president has superior power. If president is not available, then I believe vice president has the more power. Okay, so it doesn't physically exist, but I mean we call that as a system to run a country. And another definition of a system is combination of components that acts together and perform a certain objective. So to perform certain objective, we combine individual elements to make a system. So in this class, we're going to represent a system with a small rectangular box. So here is a system. Okay, that is a system. Now, the next one is plant. A plant may be a piece of equipment, perhaps just a set of machine parts functioning together, the purpose of which is to perform a particular operation. So a system can have different plants. So if you look at a system, here is a system. In this system, there might be a small subsystem. That subsystem might be a plant. Okay, that's called a plant. Next definition is control system. Control system is nothing but it is an arrangement of physical components connected or related in a such manner as to command or direct or regulate itself or another system. So control system in a simple way, if you look at a simple circuit, okay, to turn on, turn off, we are using a switch. So the switch controls the light. Okay, so but the whole circuit, so if you look at a simple circuit, so here is a simple bulb, that's the symbol of a bulb. Here is a switch, and here is a source, a battery. Okay, so I'm looking at a flashlight, basically a simple flashlight. So here the control part, so this whole thing we call that as a system, because a bulb is one element, battery is another element, switch is another element. There are three different elements connected together to perform operation. Okay, or basically it is giving you light in this case. So a control system is nothing but in this whole system, the subsystem controls the light. Okay, that's called a control system. It is an arrangement of physical component. So that's a physical component connected or related in such a manner as to command, direct or regulate itself or another system. So basically this switch is regulating the bulb in the circuit or current flow in the whole circuit. Okay. The next one is input. The input is the stimulus, excitation or command applied to a control system, typically from an external energy source, usually in order to produce a specified response from the control system. So input is nothing but the excitation. Basically, if you look at any system, that system we represent with H and input with U and output with Y. Okay, output is nothing but it is the actual response obtained from a control system. It may or may not be equal to the specified response implied by input. So basically, I mean, if you look at this simple circuit, we were talking about the flashlight. I'm going to turn on the system. Okay, I want like 100 lumens of light. You may not be able to get that 100 lumens, but you might get 80 lumens or 70 lumens or 50 lumens. That's based on the battery energy, how much energy it can supply. If battery is almost empty, it will show you only a small light. Okay, not big one. Now, as mentioned, In this class, we're going to represent a system with rectangular block. So that system we're going to represent with H, and Y is the output, U is the input. U is the input and Y is the output. The next one is open loop system. An open loop control system is one in which the control action is independent of the output. So open loop system is, it doesn't matter, it will keep giving you the output. It doesn't matter what kind of output it is. Okay, that's called open loop system. Now, I'll give a simple example. It's just like when you're driving your car, okay, your eyes are going to look at the road. Okay, if it sees some object, immediately your brain sends a command to your legs, either apply brake, or to your hands to steer in a different direction to avoid hitting that object. There it is a closed loop system because your eyes are giving, so it is taking the feedback. Your eye is taking the feedback what is there on the road. Okay, so open loop system is basically you're closing your eyes and driving your car, so it is not taking any feedback. Okay, it is not taking any feedback. Your car is going, you don't know, right, or making turns. So probably in few seconds, your car is not going to be on the road. So open loop system, there are some systems that are open loop. So here, I just got this idea. Here, I'm giving you this lecture through the YouTube channel or a video. This is open loop because I'm not getting any feedback from you guys. Okay, so whatever I'm saying, I'm not considering whether you're getting it or not. It's an open loop teaching, basically. It's an open loop system. As I mentioned, closed loop is nothing but you constantly getting feedback from the output. So this system represents the open loop. When it comes to the closed loop system, here is a simple one. So that system I'm representing with H, output Y, U. Now here I'm going to get feedback. So basically my input is going to come from here. That's my feedback. Okay, I'm taking part of the output. It doesn't mean that my output is going to reduced. Okay, still if I get 100% output, say $100, I'm not taking $1 out of it here. I'm just looking at, oh, okay, I got $100. That's all I'm looking at. I'm giving that feedback here to the system on the input side. Okay, that's called feedback. So feedback is nothing but it is a property of a closed loop system which permits the output or some other controlled variable to be compared with the input to the system so that the appropriate control action may be formed or some function of the output or input. Okay. So feedback is nothing but you're taking part of the output and you're feeding it back to the input side of the system. So if needed, you can change the input. That's the feedback. Now, continuous time control system. It is also called continuous data control system or analog control system. It contains or processes only continuous time signals and components. A continuous system is represented by differential equation. So x double dot plus 3x dot plus 4x equal to u. We know that x dot is nothing but dx by dt. Okay, so it is double differentiation, or okay, so that's a continuous system. Now, discrete time control system. It is also called discrete data control system or sampled data control system. It has a discrete time signals or components at one or more points in the system. So the discrete time control system, it is represented by difference equation. The difference equation is x of k plus 1, 3x of k plus 3, 2xk. So this is a digital system basically. Okay, that's a difference equation. I'll stop this video. I will have few more definitions. I'll continue in the next video. Thank you.